All right, so here I am with period 5. We're doing a screencast on preparing for the wave quiz or the wave test. The wave test on Monday. Any weird sounds you hear will probably come from Michael because he likes to make weird sounds. That's just something that he likes to engage in doing. That's cool. All about making the waves. So what do you think you're gonna be testing on Monday?
Soundwaves.
Soundwaves. Okay. Let's take it a little deeper, shall we?
Standing waves.
Standing waves. You will see something on standing waves. What is a standing wave? What defines one? What are the things that we have in a standing wave? Nodes. Antinodes. What else? Wave properties. What are the wave properties we have? Velocity. Talk with your mouth full. Come on. I appreciate that, but frequency, period, amplitude, and wavelength. Okay, what else? All right, types of waves. Types of waves. Longitudinal. And a lot of people want to say transversal, but it's not transversal, it's just transverse. What else? Oh, yes. V equals F lambda. How many times do we use that wave equation? All the time. All right, there's another big concept. It very slightly predates standing waves. Interference. We have constructive, and destructive. All right, standing waves. Could draw a standing wave. Series of nodes and antinodes. If I were to draw a picture of a wave up here, you should be able to do things like identify the wavelength, identify the amplitude, tell me how you would figure out things like velocity or frequency or period. You should absolutely know the definitions of each of these things, how to find them. There's two other equations that we have. V equals F lambda. What else? The relationship between period and frequency. And of course, there's V equals distance over time. Not to be confused with the wave equation. A wave travels a certain distance in a certain amount of time. So you could figure out its velocity using that, or perhaps that. All right, so that's basically a very good overview of waves. What about sound? What are some topics that we've learned in sound? Okay, so what we can hear, hearing range. What else? All right, so instrument. Instrument physics. That's a huge category. Waves on a string, waves in a wind instrument, open at both ends, close at one end. All those different formulas that you have for that, I'm not going to bother writing those down. I give you that beautiful sheet that shows you things like nodes, antinodes, length, all that good stuff. But this will probably be like 30 or 40% of the test. So you've got to be familiar with this. I'm going to give you some sample problems, and then I'll give you the solutions to those sample problems over the weekend. What else? Intensity. What do we measure intensity in? Decibels. And that whole concept of if I have one alarm going off at maybe 80 decibels, if I instead have 10 alarms going off, what would the decibel level go to? Close. That would be if I had 100 alarms going off. But if I went from 1 to 10, if I made 10 times the sound, I would get an increase in 10 decibels. So one person talking would be about 50 decibels. 10 people talking would be about one person talking would be about 50 dB. 10 people would be about 60 dB. If I increase the intensity by a factor of 10, I only go up in decibels by 10. What else? Basic things about like how sound goes through air. What kind of wave is a sound wave? Beat frequency. And the Doppler effect. I'm going to define the beat frequency for you now, and then we'll do an online simulation. The beat frequency is simply the difference in the frequencies between two closely valued frequencies. And the Doppler effect, which you guys have studied, but you haven't actually seen the videos yet. I'm going to show you those videos. All right, any questions? No? Okay.